Dear students, due to power failure, the property number 5, proof of the property number 5 was halfway down. So the proof of property number 5 will be continued now. So now, first we have taken this determinant is A1, B1, C1, A2, B2, C2, A3, B3 and C3. So this is, you can take it in a different way. I'm going to take this one is delta. Yeah. Or you can consider like this also. A1, B1, C1, A2, B2, C2, A3, B3, C3. So is a determinant. So after expansion, think that its value is delta. You can also think like that. Now, in this, every element of, suppose say this time, every element of first row, I'm going to multiply it by constant k. So by the time we are going to get the one more determinant is called delta 1. So let delta 1 be the determinant, obtained by taking k times of R1. That means every element of R1 I'm multiplying by k. Therefore, that is the determinant I'm going to give for it. That is A1, k A1, k B1, k C1, A2, B2, C2, A3, B3, C3. But according to the example, already you know that. According to the example, you know that this answer must be, first answer is delta, k times of delta. Suppose think that we got this answer is delta 1. That is delta 1 is the determinant. Now what is our aim? The delta 1 must be definitely equal to, must be equal to k times of delta. So now expanding, I'm going to just expanding along R1. So row 1 I'm going to expand. Now look at this. Plus, minus, plus. So delta 1 is equal to, look here, plus k A1, that is k A1. At k A1, vertical and horizontal get cancelled here. Look here, these two. Then B2 C3 minus B3 C2 minus KB1. So here KB1, look here, look on the screen properly. KB1 here. In this complete vertical, this get cancelled. Complete horizontal get cancelled. Therefore A2 C3. So this is cancelled. A2 C3 minus A3 C2. Plus that plus KC1 into KC1 horizontal get cancelled, vertical A2 B3 minus A3 B2. So in a delta 1 is equal to, so we have to prove this. After multiplying every element of row, this can be applied for column also. Row 1, you got the answer is delta 1. Actually, we know that this answer will be what? First answer is delta, k times of delta. Even though we thought the answer is delta 1, but it is your duty to prove that the second answer must be equal to k times of delta. Now, in all the terms, you take a k common factor. If you take k common factor, A1, B2, C3 minus B3 C2 minus B1 A2 C3 minus A3 C2 plus C1 into A2 B3 minus A3 B2. So delta 1 is equal to, first I'll write here, look here. Already might have taken this. Dear students, look here. This also will take. Now, here, that is last continuation. Delta 1 is equal to K times of, I'm going to repeat that step. Once again, I'll repeat that step again. A1, B2, C3 minus B3, C2 minus B1, A2, C3 minus A3, C2 plus C1, A2, B3 minus A3, B2. See, delta 1 is equal to K times of, all of you see now. So this is the determinant. You just see that this is like open umbrella. This whole thing is I've expanded. It's like an open umbrella. Now I'll make it as closed umbrella. So closed umbrella means in the determinant form, how we can write here? Here see that plus A1 minus B1 plus C1. Then definitely it will be first row. A1, B1, C1. So A1 vertical cancelled, horizontal means it will be B2, C3 and B3, C2. Next, remaining is automatically you can come to know this. This is the A2 and this is A3. Again, if at all you want to expand through first row, plus A1, here it is C, plus A1, B2, C3 minus B3, C2 here, minus B1, A2, C3 minus A3, C2, plus C1, this is plus C1. So C1, A2, B3 minus. So therefore here, this step you see that delta 1 is equal to K times of A1, B1, C1, A2, B2, C2, A3, B3, C3 is equal to, we have taken beginning what? Delta. Yes. Again, this is the one, proof it is completed. Or if you expand, what is delta 1 here? This one I'm going to write here. Look here. So dear students, this one yes, this is the one, theorem is completed here only, but its extension I will show you now. Here its extension is like this. Look here. What is delta 1 here we have taken? Come on, tell me what is delta 1? So KA1, KB1, KC1 and A2, B2, C2, A3, B3, C3 under determinant is equal to K times of what is delta we have taken here. So this one it is C here. Yes. Here, this is delta. K times of what is delta we have taken here. So delta we have taken what here? A1, B1, C1 and A2, B2, C2 and A3, B3, C3. So from this what we came to know that, see here once again I'll tell you there is a meaning. Suppose first we have taken a determinant, assume that its answer is delta. Second time we have multiplied every element of row 1. So this can be applied for column also, any other row also. Every element of first row is multiplied by constant k, then definitely that time think that we got answer delta 1. But we are damn sure, we are already know that delta 1 answer definitely must be equal to k times of delta. So that we have already proved here. Or you can see that second meaning. This is the determinant here. Look here. This is the determinant. In this determinant, in first row, k is the common factor. Second row, there is no common factor. Third row, there is no common factor. So therefore, any row or any column contains a common factor. Common factor can be taken outside. See, I have taken k outside. A1, B1, C1, A2, B2, C2, and A3, B3, C3. So therefore, property number 5, two ways you can express. Number 1, what is that? If every element of any row or column is multiplied by a constant, then the value of determinant is multiplied by k. Or in any row or column, there is a common factor. The common factor can be taken outside the determinant. Or we can say that every element of any row is multiple of k, then the determinant is multiplied by k. Then the determinant is multiplied by k. So many same meaning is same. Now, I hope just these examples before going to solve the problems. And this is the example now I'm going to give you. Look here. This is the property number 5. See, look at this. See, derivations you can practice it later, but you understand the concept very clearly. Now I'm going to give you this. For example, you see 2, 4, 6, 3, 6, 5, 1, 2, 9. This is the determinant. This is the determinant, okay? So overall, what is the property number 5? What it says that, look here, clearly observe that in the first row, 2 is common factor. 2 is common factor. 2 is common factor in in R1. But in rows first we complete. 3, 6, 5, no common factor in second row. No common factor in third row. 2, 3, 1. First column, there is no common factor. There is no common factor. Second column, yes, there is a common factor. Second column, again, 2 is a common factor in second column. 2 is common factor. 2 is common factor in column 2. And column 3 we go. Yeah, 6, 5, 9. There is no common factor. Therefore, what you can write? First, don't come across confusion. First, work on R1. First, work on R1. Yes, in R1 there is a common factor now. 2 is common factor. You write outside R1. First, I'm thinking about only R1. Yes, 2 1s are, 2 2s are, 2 3s are. Next, here, first rows we are considering now. Second row, no common factor. You can write as it is 3, 6, 5. And third row, no common factor, 1, 2, 9. Yes, this is the one here now. Once again, 2 times of, look here. Again, first row, no common factor. First row, no common factor. Look here. Second row, no common factor. Third row, no common factor. First row, no common factor. Yes, second column, there is a common factor. And third column, there is no common factor. Now, you can write column wise. You have to write like this, columns. 1, 3, 1. As it is, I have written because there is no common factor. But in the second column, 2 is common factor. Now you have to write like this. Outside you can take. But first common factor has to be multiplied by second common factor. 2 outside. Yes, 2 1s are, 2 3s are, and 2 1s are. And now 3, 5, 9. No common factor therefore. Like so, column means when you are working on column, your handwriting should be like this. When you are working on row, your handwriting should go like this. Look here. Now the final result is 2 into 2, 4 times of 0 I can write here. The answer is 0. Why? 1, the column 1 and column 2 are identical. In the property number 3, clearly we have discussed, and any row, any column, sorry, in any determinant, if any 2 rows are identical, then the value of the determinant is 0. So now, how these common factors, definitely while solving the problems, you will definitely come to know, while solving the problems, you will come to know how to take out common factors. Now, if that is the meaning of property number 5, if there is a common factor in any determinant, the common factor can be taken outside. But sometimes you may get confused that common factor is in row as well as column. No, first you have to execute any one operation. First you execute any one operation like. Now I am going to take one more example now here you see. Suppose see, in this case 3, 3, 6, 2, 2, 4, 5, 0, minus 5. Yeah. First, unless just immediately. First row there is a 3 is common factor. Second row 2 is common factor. Third row 5 is common factor. Yes. First row 3, first you write outside 3. First row 3 common factor. Therefore 3 ones are 3 ones are 3 twos are. Second row 2 common factor. That means you are multiple of 2 you have to write. Second row 2 common factor. 2 ones are 2 ones are 2 twos are. And third row 5 is common factor. That is multiple of 5. Again you have to multiply by 5 is common factor. 5 ones are 0 and 5 that is minus 1. But again here 3 twos are 6, 6 into 5 30 into again 0. Here 0 only. Why? Because R1 and R2 are identical. Therefore the answer is 0. But there is no rule. But sometimes now again if row and columns, sometimes row and column may be having common factor. First you have to choose any one. If you are working on rows, you complete the rows. Then you go for columns. So this is definitely you learn better. You learn better, or you will become perfect while solving different examples. So because in the problems we cannot predict that how the common factor comes. The common factor may be present in the row or maybe in the column. The same meaning here it is. See here every element of first row is multiple of 3. Here every element of second row is multiple of 2. Every element of third row is multiple of 5. Therefore the whole determinant is multiplied by those constants. Same property. So then suppose see in the column wise, if there is a common factor like 2, 2, 8, 3, 1, 0, 5, 2, 9. Okay, this one you see that. Here first rows 2, 3, 5. No. In the row, no common factor. 2, 1, 2. No, no common factor. 8, 0, 9. No common factor. Rows, no common factor. In the column, yes, here 2 common factor is there. Here 3, 1, 0, no common factor. Here 5, 2, 9, no common factor. And 5, 2, 9, there is no common factor. So here what you write, column means we have to write in the column wise. In the first column 2 is common factor, handwriting should be in the column wise. So 2 ones are, 2 ones are, 2 fours are, and 3, 1, 0, no common factor, you write as it is 3, 1, 0, and 5, 2, 9. When you are writing columns here operating, so your handwriting should go like this. Therefore, that is the one. If there is any common factor, the common factor can be taken outside the determinant. Or here, in the first column is multiple of 2, multiples of 2. Therefore, the whole determinant is multiplied by the 2. The same meaning you can go for it. Now, dear students, So property number 5, definitely when I am solving 4 marks questions, so that time definitely we'll have to work with the different examples. There you will definitely get correct idea which row from where you have to take common factor, from which row has to be taken common factor, or which column you can take common factor. Definitely once if you apply, definitely once if you work on the problems only, you will come to know. Simply giving explanation, you may get general idea now, but still the concept is not clear, means that this concept will be totally cleared when you are solving the problems. Thank you, dear students.